Hi, this is a presentation on safety instrumentation, including safety integrity levels, SILs, all to do with safety management, by Steve Mackay. And in 10 minutes, we're going to do a quick whistle-stop tour through it, just to talk about some of the key issues on safety management and SILs and safety instrumentation. So where are we now? And obviously, it can't possibly happen to us, which is the usual catch cry. Here's an example of a particular bad disaster. Teacups were tinkling, kettles whistling, no problems at all, and all of a sudden, at the chemical works, massive blast, 28 killed in a very quiet little part of England. So, temporary, faulty piping design, poorly qualified design team. Another disaster in Italy, similar sort of problem. Toxic residues go missing, eventually found incinerated. So this is to do with TCP, which is obviously not very healthy. Nuclear, another one, nuclear power station. No one actually hurt here. Well, no one killed, but perhaps toxic radioactive cloud which releases probably going to cause worse damage over a longer period of time. And here there's an issue about cognitive overload. In other words, the operator's been inundated with too many alarms and not able to do it. Opal's another particular bad one. 3,800 people died, 11,000 disabled. Absolutely unimaginable disaster. And of course, the company Union Carbide has was bankrupted. Another one, Milford Haven. In fact, just before we ran a course there, and again, operators lacked adequate information to make decisions, and some alarm overload as well. So particularly bad. Mexico. Overpressurization, and the last one is BP Refinery. Again, so these are all issues which need to be dealt with. Can't possibly happen, but it does. So just to briefly talk about safety basics, safety instrument system, we're going to use the word SIS, and that's equivalent to a trip system, shutdown system, instrument protection system. And it's an example of a functional safety system. So the other term which we're going to use, which we've quoted in the introduction, is functional safety, which is a part of the overall safety relating to process, which depends on the correct functioning of the safety instrumentation system and other protection layers. So there's two standards actually, 61508, which is the overall standard, and then 61511, which is focusing on the process side. So particularly critical. At the moment, if you look at a control loop, you see something like this: sensors, output elements, and of course the controller. So big problem there is, even though you will probably build some safety into here, you probably need a lot more than that to be absolutely safe. So the protection system is what we're going to look at now. Separation of the safety controls from the process controls. So scope of a safety instrument system, a SIS, is from a sensor, logic solver to the actuator, and it will operate even though the process control system doesn't. So definition of a safety instrument system as per this diagram: sensors, logic solver, actuators, three subsystems. System basics, safety system basics, really what we're trying to do is reduce the hazard, which is an inherent physical or chemical characteristic which can cause harm to people, property, or the environment. The environment could be something like pollution. So what is a hazard and what is a risk? Let's quickly define what this is. A hazard is, as we just spoke about, something which is going to cause harm, and a risk is two elements: the severity, how bad a disaster is it, and the probability of that severity occurring, a chance. So the two multiplied together give you the risk. And here's a simple shutdown example. I'm not going to worry too much about that. You can look at the slides. risk reduction is what we're looking for. So we're looking for some way of reducing the risk so it's tolerable and thus all reduced. So we can either do two things about risk reduction. You can either reduce the frequency of the hazard or reduce the actual hazard, the actual consequences. So here's an example with cricket, which of course Dave McDonald put this together, is an avid cricketer. So the measurement of risk here is you can do either do it qualitatively or quantitatively. Quantitatively is more attractive, but of course in the engineering world you can't reduce everything to numbers, unfortunately. It also is some qualitative. So here's risk and frequency. So here's a minor injury frequency curve, fatal. So the risk is obviously greater here for a lower frequency. So risk is frequency of event times consequence. So reduce risk, obviously the trick is to reduce the consequences and obviously the frequency. Try and get it into a nice little area down there. So this is risk reduction design principles. Identify the hazard, estimate the risk, look at the risk reduction requirement, go around till you get a tolerable risk, and then you define your SIL target. So the safety control system, as we said, operate independently and achieves risk reduction. And the idea is that you use a thing called a target safety integrity level, which is what I just want to spend a few minutes talking about now, a SIL. So here's different safety integrity levels. This gives you the degree of confidence placed in the ability of the system to provide functional safety. So this tells you the quality of care taken to avoid systematic errors in design and maintenance. So this is different types. So for example, a SIL 1 is between 10 and less than 100, or probability of failure on demand greater than 100th, but less than 1/10th. And here's SIL 4, which is greater than 10 to the minus 5, less than 10 to the minus 4, probability of failure on demand. So just to give you a quick idea of what SIL means intuitively, a SIL 1, if you've got a safety instrument system with availability of 90%, high-level trip in a liquid tank, availability of 90%, 10% chance of failure, means 1 out of every 10 times the high level is reached, there would be a failure. So consequent overflow 1 out of every 10 times. So that gives you a SIL of 1. And you need to obviously assess whether that's adequate for your system. If it's not, then you may need to look at a higher SIL level to deal with that particular problem. Depends on the risk, which is obviously the hazard multiplied by the probability. So that's it from me, Steve Mackay, giving a quick rundown on safety management, safety integrity levels, risk. Thank you very much for attending this session. Really appreciate it, and hopefully there was some benefit in reviewing the slides.